Welcome back, everyone, to the second episode of Clear Signal, where we talk about the applications and advancements in imaging radar. Today, we're focusing on safety and collision warning around heavy equipment.
Yep. So this is a big topic. We have recently visited a major port in Jamaica, and our customer was very interested to install our guard system around these massive machines called straddle carriers. These are like 70-ton big vehicles that move around in very tight spaces, and there are a lot of potential accidents that could happen. And when the accident happens, not only there is going to be massive financial risk, there will be downtime that will really cause even bigger financial problem. So this system is very useful. They love the system. And you're one of the architects of the system. So I would like you to describe what are the components of the system and how does the system work and how does it compare to systems based on cameras and LiDARs?
Definitely, yeah. So when we were designing and architecting Fleet Guard for this customer and other customers in the similar space, our number one, focus was how can we reduce accidents, how can we reduce downtime, how can we deploy the system to as many different platforms as possible, and how can the system, prevent collisions while staying out of the operator's way. And when we were looking at all the different sensor modalities and all the different options we had out there, we have a camera, we have LiDAR, we have ultrasound, but as a company, we also develop high-performance imaging radar. And so based on the merits of our radar technology, we found that radar is like the premier modality to use for this use case. And we've architected Fleet Guard to basically have a flexible number of radar sensors you can place in key areas around your machine. And these sensors all connect to a centralized control unit that ingests the data from the radar and turns it into basically a collision warning map for the driver. And then this information is then piped to the operator cab, driver unit, and we have like a touch screen and we have some, alarms and speakers in there for the driver.
Right, great. Yeah, so what we noticed was for port operation, not only they have a straddle carriers from a certain company, they have different companies that provide the same type of machine. And there are many other types of vehicles that are also big and running into, other vehicles or people and potential damages. One advantage of this system is the scalability that we could apply this to many other types of vehicles. How do you go about applying this Fleet Guard into another type of vehicle? Let's say reach stacker or stacker or forklift. How easy is it to take this system that is designed for one platform and make it work for another platform?
Yeah, so that was one of our main goals when designing the system, is to have it be flexible and adaptable to different platforms. And this is because when we're deploying these like retrofit collision warning systems, a company or a customer may not have all of their entire fleet be just one type of vehicle. For example, in port operations or in mines, there are many, many different types of vehicles that are being used, and they're all, collisions from any vehicle to any other vehicle would cause downtime. So we've designed our system so that during the initial survey phase, we can come and take a look at the critical areas of the machine that need to be covered with the sensor. And then we can install our sensors based on our flexible mounting platform that can go in many different locations on a platform. And then we can modify our collision warning perception stack to basically provide coverage for any really type of vehicle. And this could be for simple vehicles like trucks or forklifts, or more complex vehicles like reach stackers, like straddle carriers that have all kinds of different moving parts, areas that come up and go down, even collisions that could happen at the ground level or even far off the ground.
Yeah, what I noticed when I was there, working and sitting next to the operator, 60 feet up there, it's hard, by the way, was that these operators get really actually frightened when another type of system was constantly telling them that there is an accident, and they would eventually actually turn off that system because there were just so many false alarms that got them really scared, and they thought that the system itself was a threat. So, how do we alleviate that problem? What we noticed was that our system had extremely low false alarm rate, and that was a design. So can you tell me what was going on in the design using the radar that enabled us to have such low false alarm rate?
Sure, yeah. So it's very important for a collision warning system to have a very low false alarm rate because these operators, highly trained operators, are operating under time pressure in very busy and crowded environments, and the mental load is already very high. So if you have a number of false alarms going off left and right, that's just a further distraction for the driver. So to drive this false alarm rate down, we lean into some of the strengths of our imaging radar platform, our software-defined imaging radar platform. We use the high resolution and strong attention-based perception algorithms to detect when a incoming obstacle is like truly an obstacle, or if it's just, let's say, I don't know, some noise, for example.
Yeah, so what I noticed was that this massive machine is moving toward what seems to be an obstacle, but because we know the direction of the motion and we have this predictive nature of our system, it knows that you're not hitting this obstacle, even though it is crossing by like only 30 centimeters from the obstacle. So we're not sounding an alarm, even though the obstacle is very nearby, but we know so accurately that we're not going to hit it. And that was a feature that the operators absolutely loved. So I would like to switch gears a little bit. Can we use cameras also on our platform? Do we make any decisions based on the camera image?
Yeah, so cameras can be installed on our system, but we don't use visual feeds as part of our collision warning input. And the reason for this is because cameras, are subject to different lighting conditions. If you want to run operations at night, if you're working in a muddy, dusty environment, these are all things that just cause more maintenance downtime if the lens is covered, for example. But we do support camera installation for driver aid. Basically, if we install a number of cameras all around the vehicle and we detect an incoming collision in one direction, we can actually bring up that video feed and maximize it for the driver so that they know exactly where to pay attention to.
What about a sensor like an ultrasound? Do you think ultrasound has any utility for such a system? Is there something that ultrasound sensors can do that like radars can't do?
Yeah, so ultrasound is kind of what you typically think of when you think about like low-speed collision warning. If you think about like parking assist on your car, this is all typically based on ultrasonic sensors. But around complex vehicles and complex environments, the data you get from an ultrasound sensor just doesn't have any real resolution and doesn't really tell the system anything about the environment. It really just tells you if there's something nearby, near that ultrasound sensor or not. But we're doing some much more advanced collision warning processing using our radars. We can measure, how far away different things are in the environment, where they're using the radars alone, measure, like you mentioned before, the movement and the direction of the vehicle itself. And so, having this additional information means that we can intelligently predict when you're going to actually hit a real object.
Yeah, that's great. Another point that I've heard from people that use ultrasound is like the interference problem. Ultrasound could have a lot of false alarm just because there could be some vibration in the environment and the sensor just goes off even though there's nothing to worry about, and that's an annoying factor. Yeah, from what we have seen, there's nothing an ultrasound sound system can do that the radar system cannot do better or equally good. Another factor is like the speed is much faster, and you could have the pulses that are much shorter in time, and the reaction time is certainly much more favorable. Mm-hmm. We have applications in the mining How does this work for a system that is a tunnel? Do you think we could use this system for a mining equipment that works inside a tunnel?
Sure, and we've even, tested and deployed radar systems that operate underground in tunnels. Actually, tunnels are a bit of a strength of ours because of the beamforming performance that we have in our Z Prime and Z Pulse imaging radar platforms. These radars have extremely, extremely good azimuth and elevation resolution. And so when you're inside an enclosed space like a tunnel, you've got the roof, you've got the walls, you've got the ground. Even though there are all these reflections coming left and right, our system can accurately distinguish where the walls are, where obstacles are very cleanly.
Yeah, and I guess inside the tunnel, the lighting is probably not very favorable,
Oh, yeah.
and the dust and all sorts of
Underground.
So it'd be any optical system would massively suffer from the environmental issues. Is there anything else you would like to discuss about the Fleet Guard?
I mean, yeah, so like these are real world environments, and in the real world, in these, high stakes environments like mines, like ports, things are dirty and downtime is very expensive. So, we're excited to be putting out the sensor technology, the fundamental, perception algorithms, and the collision warning system together in Fleet Guard so that we can improve safety and decrease downtime worldwide.
One last question. Is this system software updatable over the air?
Yes, so that's one of the big asks that our customers have is when the operators, use the system and they find that there might be too many, alarms in this one area. Or if they would prefer the system to behave slightly differently, can we go in and can we update the collision warning system for their operators? And the answer is yes. So we have a very flexible collision warning platform along with our detection software. And the combination of these two, plus our software upgradability, means that we can go in and based on driver feedback, operator feedback, we can go in and we can tune settings and detection and almost anything to exactly what you need.
Yeah, and this whole thing could be done really just over the air.
Correct.
Like, they just need to be connected to a Wi-Fi, and that's it. That's all we need.
Exactly, yeah, and we can provide remote support.
Exactly. Well, thank you so much for all the great information.
Thanks, Mazi, for your insightful questions.